So last class period, we talked about the distribution of sample means and how to take sample means, put them on that normal curve. Today we're going to talk about the distribution of sample proportions. There are many instances in which the variable of interest is a proportion. A manufacturer would be interested in knowing what fraction of his manufacturing components are defective. A marketing researcher would be interested in what proportion of persons on a mailing list will buy the company's product. A college would be concerned with the fraction of freshmen that may be academically struggling after their first year. Population proportions must be estimated just like population means. So, P represents the population proportion, and P hat represents the sample population. Don't forget, P hat is what we call that, it's a sample proportion. So, determining the sample proportion. There are two different ways you can determine the sample proportion. The first way is if it's directly given to you. Okay, so you might be given the proportion in the problem. An example of that would be like a sample of 400 households in Hays, Kansas, found that 44% have cable television. Okay, well that means that P hat is 0.44. Like they literally tell us. That is what it means by directly given. Okay, they might give you the proportion in the problem. Or it may be given to you in a frequency table. Again, that's still directly given. So frequency distribution for rolling a die 150 times. So I rolled this die 150 times. I got 24 ones, 27 twos, 18 threes. The relative frequency, which is 24 divided by 150, or 27 divided by 150, or 21 divided by 150, that is the proportion. Remember, those all have to add up to be 1. Okay, so like that would be another way that it could be given to you. The other way is if they didn't give you, it's not directly given to you, you might have to calculate the proportion yourself. Okay, so calculating the proportion, we should know is x over n. Another way, and we've talked about this in the past, it's what you want over the total. Okay, what you want over the total. So the sample proportion is given by P hat equals x over n, where x is the number of observations in the sample possessing the characteristic of interest, what you want, and n is the total number of observations in the sample, the total. So again, proportion, what you want over the total. So number 3, it says, suppose you are trying to determine the proportion of manufacturing components that are defective. If you select 120 components at random and 38 components are defective, what is the proportion of defective parts? So this one they did not give to you, you have to calculate it. Again, calculation is what you want over the total. What is the proportion of defective parts? We want defective, and it says there's 38 that are defective out of total, and they said there's a total of 120. So that proportion would be 0.32. Okay? On number 4, we're going to learn something new. Okay, this new thing is literally not the point of this lesson. It's to help you in the future. So it says, for data in Excel spreadsheets, you may also have to count the number of observations possessing the characteristic of interest before calculating your P hat. So it might not be like there's 38 out of 120. It'll be like give you a table of values like so, and it'll be like find the proportion of this, and you would have to count it. It is not time efficient, nor is it the best possible way if you go through and literally count by hand. So that's why we're going to learn now this Excel command called COUNTIF. And what that's going to do is that's going to count something for you. So I'm going to come down here, and let's say I want to ask the question, how many have red hair? Okay, that's what we're trying to figure out. We have all of these guys here, and I want to know how many have red hair. Well, to do that, we're going to use the COUNTIF function. And the COUNTIF function literally means we will count it if it has these stipulations that you put in play here. So I'm going to type in equals COUNTIF and then an open parenthesis. Now you'll notice the first thing they want you to do is highlight the range. So the range is the table that we are given. So if on Hawks Learning they give you a table, you'll have to copy and paste it to Excel. That's my range. Comma, the next thing we have to do is put the criteria. Well, the criteria here is if they have red hair. Now the criteria that you want them to look for, you have to be specific. So we're going to put it into quotations. and we're going to put the word red. Okay, it can be capital, it doesn't have to be capital, it'll count it either way, and then you'll close your parenthesis. So we're saying, in this range, count it if it says red. And that says we have 5 that have red hair. Does that make sense? Let's try it again. Let's see, I come over here and say, how many do not have brown hair? Now, some people would look at this and be like, okay, well, there's brown, black, blonde, and red. I could go through and count the black, the blonde, and the red. That would work. Or some people will go through and be like, okay, I know how many there are, so what if I do count the number of brown hair and then subtract? That would work too, but I'm going to teach another way, okay? So again, we're going to do equals count if, open parentheses, highlight the range, comma, then we're going to open quotations here, and we're going to do less than, greater than. That symbol right there. That means is not or does not. Okay? So that means count if it is not brown. Okay? So put the less than, greater than. Is not brown. Do not put a space after that less or greater than symbol. Do not put a space in between that and brown. Then it will not work. If you do that, it'll come back with 50 because none of them have a space in between that brown. We don't want that. You don't want the space in between that. So that means there are 18 subjects that do not have brown hair. Are we okay with that? Yeah, I'll click on it one more time. Less than, greater than. Make sure to put quotations around it too. The 5-1 was count if, highlight the range, and then red. Make sure to put it in a quotation. All right. Now, when it comes to numbers, like that was just a table of like actual words. When it comes to numbers, you actually have a little more leniency or leeway on what you can do. So for example, here's just a bunch of numbers that I've given you. Let's say I wanted to figure out how many are less than 30. How many are less than 30? Well, I can still use the count if function on that. And I can highlight my new range. And for my criteria, in quotations, we would put less than 30. It'll count that for you, less than 30. And that should give you 26. Are we okay with that? That should make some of these calculations a ton easier for you. So now I want to do one more. How many are between 21 and 25? Now before we do this one, I want you to think about it. Between 21 and 25. Okay? Between 21 and 25. And then watch what I type in. Equals, count if, highlight my range, and my criteria is going to be less than, equal, 25. That's how you type less than or equal to. Less than, equal, 25. And then I'm going to close that quotation and close that parenthesis. Minus, count if, highlight my range, quotation, less than 21. So I'm going to hold that up there for a minute and then we'll talk about it. Okay, so you, oh, what did I miss? We found a typo. Oh, the quotation marks. No. Okay. I just forgot to end my quotation marks. There you go. So you should get 14. Now let's talk about why that is. The first one said count if it's less than or equal to 25. So if I have all of these numbers, right, here's the number of numbers that are at the number of ones, the number of twos, the number of threes, all the way up to the number 21, the number of I need to scoot over a little bit. The number of 22s, the number of 23s, the number of 24s, and the number of 25s. So the first thing that I have in my cell is count the number of numbers that are less than or equal to 25. So first of all, I'm counting all of the numbers that are less than or equal to 25. Okay? And then it says count the numbers that are less than 21. So that would start at 20 and go all the way to 1. And it's saying take this first guy and subtract this second guy. Okay, so this is x and this is y. And that's going to leave me with 21 to 25. Notice how the first one is less than or equal to 25. I'm including that. The second one is not less than or equal to 21, because if I did that, it would get rid of that, and we don't want that. So it's just less than 21. Are we okay with that? You got 16? Let me look. So the COUNTIF function can definitely be used to make some of your work go faster, so you don't have to sit there and be like, well, how many of these do I have? How many of these do I have? How many of these do I have? Okay, that would have made it a lot faster. Okay, now, just as the sample mean was a good estimate of the population mean, the sample proportion is a good estimate of the population proportion. Similarly, just as the sample mean varied depending on the sample selected, like it depended. Remember we talked about how, like, if I were to find the average height of this sample, it's going to be very different than the average height of this sample. It depends on the sample that I selected. The sample proportion is going to vary depending on the sample that you're going to choose. Okay? So since p hat varies, since my sample proportion varies, 3 familiar questions must be examined. Okay? The first question that we have to examine is, what is the central value? The expected value of the sample proportion is the population proportion. Symbolically, this is expressed as the expected value of the sample proportion equals the population proportion. Like, that's what we're trying to get to. Since the expected value of the estimator is equal to the population proportion, then this is an unbiased estimator. So do you remember when we had that example and we found every possible sample mean that we could, every single one? There were the 6 valves and we chose 2. And so we said we could make 15 different groups of 2. We found the sample mean of every single one of those groups, and then we took the average of all of those sample means and we got the actual population mean. Do you guys remember that? They're saying the same thing would work for the population proportion and the sample proportion. If I were to find every single possible sample that I could and find every single proportion of those samples and then find the average of them, I'm going to get the population proportion. But they're telling us that's true, so we don't have to do it. The next thing they're going to ask is, what is the variability? Well, that means we're going to have to figure out the standard deviation. To find the standard deviation of the sample proportion, we need to use this formula. Okay, so last class we learned how to find the standard deviation of the sample mean. This class we have to use this new formula, which is the standard deviation of the sample proportion. And that's going to equal the square root of p, which is your population proportion, times the quantity of 1 minus p divided by the sample size. Okay? Now, something they don't have on here that you guys should be aware of is if they wanted you to find the variance, remember it's just the square of that, so it's just p minus, or times 1 minus p over n. If you should need to use that, they probably won't give it to you. They'll only give you one or the other, and you'll just have to remember that one is the square of the other. Okay? Now, let's do a little bit of practice with this, just so you understand how the formula works. My first little example here says, let's say I have a sample size of 25 and my proportion, or my p-value, is 0.25. So to find my 1 minus p-value, I just type in equals 1 minus, okay? Now I want to try to find the standard deviation of my p hat, okay? And we can do it all at once. We're going to type in equals square root of, and underneath the radical, it's just, we have multiplication over division.